Okay. Next we have the project team from the Americas Resins business. The members of the Lexan team will now present Free Plants.
Time keeps on slipping, slipping, slipping into the future.
Good morning. I'm here today for Bill Driscoll, who after a quadruple bypass 2 Sundays ago, is recovering at home. Good luck, Bill. Vision 2000, everything starts from Vision 2000. It is less than 18 months away. Time is short, and there is a lot to be done in order to meet our targets. The Americas QFD called for an increase in our sales of $1.3 billion. This is a huge number to make, and we absolutely know that we cannot do it without the Lexan business, our big mama. The Lexan QFD called for production capacity to jump by 300 million pounds by the year 2000. We need this 30% increase in capacity in production in order to be able to serve better our customers, to cut the lead times. But there is a very big difference between putting it down on paper and make it happen. So Bill called on Sherry Dick, our Lexan Chem Ops manager in Mount Vernon, and gave her one very simple directive. I cannot do it like Bill, I do it like Nani. We need more, we need it better, we need it faster, and we need it now.
Well, there's only one good response to a challenge like that. No problem. Just give us $150 million and we'll have it for you by the year 2000.
And I think that Bill answered, no more money. We need free capacity, and we need it now.
Well, that was pretty clear. What we needed was an increase in capacity, improved quality and service, and we needed to drive profits. What we needed was one free Lexan plant. That's not a big why, that's a huge why. But we had some bottlenecks. The big crunch was in BPA, where we were purchasing $1.4 million each year because we couldn't supply ourselves internally. So with the focus in BPA, we needed capacity, but we had to protect quality, and we had to watch those phenol levels and keep them in spec. So with this challenge, I did what any good plant manager does. I called the BPA manager.
Hi, Sherry.
Rob, I need you to produce 50 million more pounds of BPA each year, but you've got to keep those phenol levels in spec. Can you do that?
Sherry, we can do that, no problem. All we'll need is about $50 million.
Whoa, whoa. Let me explain it to you the way it was explained to me. We need 3 BPA now, and it has to be fast.
Let me tell you, a challenge like that changes your whole world. To deliver the additional 50 million pounds of capacity, we'd have to increase the phenol desorption process. If it was that easy, we'd already be doing it, but it wasn't. So I did what any good manager would do. I turned to my process black belt. Scott, we need to talk. We need to increase the capacity of the BPA desorbers.
No problem. We can do it right away.
What do you mean? What have we been waiting for?
Well, no one's wanted to fork out the 20 million until now, but since you're ready.
Just a second. I guess I didn't make myself very clear. Not only do we need to increase the capacity of the BPA desorbers by 50 million pounds, it has to be free. The desorbers have to process more, better, faster, now.
Well, our goals were clearly defined. We had to increase desorber throughput and BPA capacity, all the while maintaining phenol in spec. What wasn't clear was how we were going to do that. I knew it was time to call on the doctor, Dr. Krugeloff that is, whose specialty is curing large engineering headaches.
They have a saying in this country, the buck stops here.
And it sure did.
The first thing I wanted to do was to make sure we could get accurate measurements.
No problem there, Lexi. We performed the gauge R&R, and BPA checked out at 4.7%, and phenol checked out at 12.5%. With our measurement systems confirmed, it was time to move on to making more, better, faster, now.
You guys are getting good at that. Can I hear you again?
More, better, faster, now.
Great job, team. Thanks a lot. Now, about the money.
No!
Okay. Well, our next step was to establish our process capabilities. We began with 25 variables, but benchmarking BOZ helped us to quickly narrow down our vital axes. At Mount Vernon, it was time to go to the plant and find our sweet spots. Before that could happen, we had to figure out why our phenol concentrations increased whenever we increased our rates. So I designed this beautiful, full factorial DOE that included 32 experiments in the plant.
Wait just a minute, Alexei. I think the good doctor needs a dose of reality. There is no way running 32 experiments like that was going to be good for our plant, no matter how good it looked on paper. It could have shut us down, or at least seriously compromised the quality of the product we were already running. And besides that, it would have taken 9 months. The fact was, if we messed up with our existing customers, we wouldn't be needing any more capacity.
Celeste was right. Since we didn't have time and wouldn't risk product quality, we decided to build a virtual DOE using an ASPEN model. How was that for more, better, faster?
Right. Anytime we can get information without putting product quality at risk and save time, I'm all for it. The ASPEN model provided us with the data we needed to find the experimental range for each variable. With this tool, our sweet spots popped out.
By the time we were finished, we had a new way to operate our plant. We had rewritten procedures and trained all personnel on the changes. Our X's were controlled in DCS, and all of our process modification reviews had been completed. Look, we can talk about statistics and fancy graphs all day, but what we're really talking about here is trying to figure out ways to help operators get the most out of their plants. It really is that simple. We used to fight the desorbers and have to watch nearly 20 different things. Now we track 4 and they nearly run themselves. We're more productive, we're improving quality, and reducing variability every day. Everyone keeps talking about wanting to operationalize Six Sigma. I'm here to tell you that the way to get operators interested and involved is to help us do more, better, faster, now.
And you know, Rob, it didn't stop in Mount Vernon. This program has been all about translation and global teamwork. The translation package that the team put together has already been implemented in Burkeville. And for teamwork, this project is the outcome of one of many Lexan global teams. These teams have been working enormously hard, learning from one another, communicating, and exchanging Cupid projects worldwide. One team even went so far as to take advantage of a difference in equipment to conduct a DOE in Bergen-op-Zoom in order to improve the performance in Lexan resin in Mount Vernon. So far, these teams have cut costs, they have reduced methylene emissions by more than 70%, and for capacity, the capacity entitlement that these teams have developed free and that we're already tapping into is more polycarbonate than was produced last year in Dow Chemical's US operation.
That's right. Our team is here to charge ahead into the results of this project. Nani, we found your free plant. We've increased our BPA capacity by over 55 million pounds. And we are well on our way to meeting our Vision 2000 goals. In fact, we're no longer buying BPA. we're now selling our surplus BPA, returning over $2 million to our bottom line. All of this was accomplished while avoiding that $20 million investment cost.
No money.
We've decreased our DPMO by 99.8%. And we've added an additional $25 million of operating margin to our business. But none of this would matter very much if it didn't mean better things to our customer. So it is with great pleasure that I introduce one of our own Lexan customers, Ken Perkins of Floraware, to tell you about it.
Jesus, Mike. It's no secret that in 1996, polycarbonate was tight worldwide. The situation was so bad, we were very hesitant to specify Lexan in any new applications. Since that time, I'm here to tell you the situation is very different. The work done by this team to increase capacity, maintain stability, gives me great confidence that I'll have Lexan when I need it. Today, service is good, lead times have been cut. Because of that, my customers are benefiting from increased supply, faster supply, and because of that, they're able to bring new products to market faster than, and because speed is the important key in bringing new products to market in the semiconductor industry.
Our team is here to tell you,
Six Sigma
begins and ends with our customer.
Okay, now the big one. And if I know this crowd, there's going to be a lot of partying somewhere later tonight. And so you may want to find out where they are and get on the other side of the complex. But come a long way in 12 months, done a terrific job. It's the team from the Americas.